All right, let's work through it and see how we did. So in this first square, we get a 9i squared. But 9i squared is the same as 9 times negative 1. So what you really should have in this first square is a negative 9. And then you have a negative 6i, another negative 6i, and a positive 4. So now you're ready to combine your like terms, and these will be like terms, and these terms are like terms. So my final answer would be negative 5 minus 12i, and you can also flip that to negative 12i minus 5. So either one of those would be perfectly fine for full credit. Who had that answer by chance on the bell work? All right, so go ahead and make a correction if you did not get that answer. Yesterday we started Appendix 10. That video is posted if you are absent, or even if you want to rewatch it and get the notes. That material will not be on the skills check tomorrow though, because the skills check tomorrow is just over 7 and 9, not 10. Okay. So go ahead and copy down. We did 10 and 11 yesterday, so we're on 12 and 13. So take a minute and copy down 12 and 13. Yes, those fractions are exponents. So we just need to remember our exponent laws. When you multiply two terms that have the same base, what do you do with the exponents? You add them, yeah, and that's exactly what we're going to do. In order to add fractions, you need a common denominator, and we already have a common denominator, so we don't need to rewrite the exponents to get common denominators. We're just going to add. So this would be x to the power of 7/3, which can also be written as a radical. So remember, your denominator is your index, so that would go here. And the power goes here. Now the power can also be written on the outside. So this is also an acceptable way to write your answer. All three of those have the exact same meaning though. All right, so for question 13, we're doing the same thing. First, we're going to add. So that would be b to the power of 10/4 over b to the power of 1/4. And then you're going to subtract. So 10/4 minus 1/4 is 9/4. Which again can be written anytime your exponent is a fraction. You can also write that with a radical. So that would be the 4th root of b. That's what that means. Your denominator is your root. So that's the 4th root of b, and the exponent is 9. You can also write that as the 4th root of b and put that 9 on the outside. So Appendix 10 is all about powers, simplifying powers, multiplying, adding, dividing powers. So now let's look at multiplying. So take a minute and copy down numbers 1 and 2. And then we'll do 3. 3 might take a little bit more space. So I would just copy down 1 and 2 for now. And then we'll go, and I'm going to add a new question for 4. So 1 and 3 are both multiplication, but they're different. Let's look at how they're different. Notice how we have a minus and a plus sign in between. So in order to multiply number 3, we have to do first, outer, inner, last, or make a box. But for number 1, this is one term, and this is one term. So we just multiply. We don't have to do first, outer, inner, last. Okay, so we're just multiplying our numbers. So in this example, I would multiply the 5 and the negative 3. And then I'm going to multiply what's underneath my square root. So if I multiply 5 times negative 3, I get negative 15. And then 8 times 3 is 24. But you have to be careful. Anytime you have a square root, you have to simplify it. So 24 is not a perfect square, but there is a number here in this list of perfect squares that will divide evenly into 24. And that would be 4. So you're going to take that 24 and break it apart to 4 times 6. So we're going to break this apart. Let me write over here. So it's going to be negative 15 times 4 times 6, which becomes negative 15 times 2 times square root of 6. And you can multiply the negative 15 and that 2. So your final answer is negative 30 root 6. And that's how you would multiply. So I'm going to do these out of order. I want to do number 3 next. And then we'll talk about number 2, because number 2 is adding. So let's look at number 3. Number 3, we have to make a box. So let's make a box. And go ahead and fill in those 4 boxes. So in this first box, I have the square root of 25. And the square root of 25 is 5. And then I have negative 2 times root 5, and that would just be a negative 2 root 5. And then I have a positive 3 root 5 and the negative 6. You always check to make sure, can you simplify what's underneath the radical? And 5 cannot simplify any further. Now, in order for you to add these together, because we can add these together, these are like terms. The only way you can add is if you have the same number underneath the radical. So do you see how they both have a 5? That means I can add the coefficients together. So I'm adding together, in this example, I would add the 3 and the -2. And then I would also add the 5 and the -6. So my final answer would be -1 plus 1√5. Or you could just say -1 plus √5. And the order that you write those terms does not matter. So if you put √5 minus 1, that's also right. So I know I'm like ignoring 2, but I'm going to get to 2, and I promise you I will. I want to add one more question now. I want to do a number 4, because I want us to really get this multiplication down, and then we'll get to addition. So go ahead and copy this down, this question down. And we're going to make a box and multiply that out. Yep, you sure can. Okay. So let's fill in our 4 squares again. So I wanted to do this one because I want you to see what it looks like when you don't have like terms. So we're not going to have like terms like we had in number 3. Because oftentimes when you're multiplying radicals, you don't have like terms. Okay, so first we have 2 times 3, which is 6. And then I have 2 times √3, which is just 2√3. -√8 times 3 is -3√8. And then I have a negative square root of 24. All right, we have to do some simplifying before we can try to finish this out, because I want you to notice, even though I'm done, that's my answer. Excuse me, thank you. 2 of these square roots can be simplified. So this 8 and this 24 can both be simplified. So we need to simplify those first. So I'm going to simplify -3√8. So if I take that -3√8, what's the perfect square that goes into 8? Perfect square. 4. So I can take the 8 and split it apart to 4 times 2. Square root of 4 times the square root of 2, which is going to be -3 times 2√2, which is -6√2. So that's really what I have in this box. So this box is really a -6√2. So I'm actually going to erase that and put that in this square, because that's really what's in this square now that I have it simplified. And now let's do the same thing with that square root of 24. So negative square root of 24. What is the perfect square in this list that goes into 24? 4. 4 times what is 24? So that would be a negative, and then I have a 4 and a 6. So that becomes negative 2 root 6. And that's what's really in that square. So now we're ready to write our answer. And what I want to make sure you understand is that none of these are like terms, because all of these square roots have different numbers. That's the square root of 3, that's the square root of 6, and that's the square root of 2. So I can't add any of these together. So my answer will have 4 terms. And my answer is going to be my final answer will be 6. And the order that you take these out, that doesn't matter also. As long as you have 4 terms in your answer, they don't need to be in this exact order to be correct. And that would be your final answer. Okay, so we're almost done. Let's look at number 2, and then we have 3 more questions. But of those 3 questions, the last 2 are very, very easy. So, all right, so let's look at number 2. So now we're ready to focus in on this question, number 2. And again, we have to simplify. So 18 can be simplified, and so can the 8. So I want you to take a minute, try to simplify both of those. So you're looking at this list of perfect squares, figuring out what number goes into 18 and what number goes into 8. All right, so we have a negative, and then I have a square root of 9 times the square root of 2, which becomes a negative 3 root 2. And then for here, I have a 2, which is going to break down to 4 times 2. So that's going to be 2 times 2 root 2. Let me bring this down a little bit. And that's going to add to be, multiply to be 4 root 2. So do you see how we have like terms now? These two are like terms, so I can add. But when you add, you're only adding the number in front. So I'm only adding these 2 numbers right here. You do not change the number underneath the square root. So negative 3 plus 4 is 1. So your final answer would be 1 square root of 2. Or just square root of 2. You don't have to put that 1. It's like saying 1x or just x. It's the same thing. And that would be your final answer. I know there's a lot happening on that screen, but this is your final answer right here. Square root of 2. Or you could say 1 square root of 2.
Okay, so when you simplified the radical of square root of 8, and I got 2 plus 2 square root of 2.
2 times 2 square root of 2.
So it's not plus.
No, so you right here you put a, did you say you put a plus sign in between here?
Yeah.
No, you don't put a plus, because when I break, so you see how the operation happening between these two is multiplication, not addition. So there's not a plus in between here, so we can't add a plus sign. These are being multiplied, so when we separate it, it's still multiplication. Okay, just a few more questions and we'll be finished for today. So let's look at question 5. And then don't copy down 6 or 7. Those go really fast. But remember when we talked about I, we said we can't have an I in your denominator? Well, the same thing applies for a square root. We're going to multiply by the conjugate of your denominator. So what do you think the conjugate of root 2 minus 1 is? Root 2 plus 1. That's what we're multiplying both by. So in the numerator, we have 5 times the square root of 2 plus 1. And in our denominator, we have to do first outer inner last or make a box. But we're multiplying root 2 minus 1 times root 2 plus 1. So take a minute and see what you would get, and then we'll go through it together. Okay, so when you distribute the 5, you would get 5 root 2 plus 5. And then in my denominator, this first square here, root 2 times root 2 is the square root of 4, and the square root of 4 is 2. And then in this box, I have a negative square root of 2, and then I have a positive square root of 2. So these two cancel each other out, which is what we were trying to do, which is why we multiply by the conjugate. And then the last square, we have a negative 1. So our like terms are 2 minus 1, which is just a 1. So my final answer can be written like this over 1. But you don't have to. Whenever your denominator is 1, we don't have to write that. So you could also just say 5 root 2 plus 5. So either one of these answers would be perfectly fine on the test. And our goal again for division is to not have a radical in our denominator. Just like in I, we cannot leave that there. All right, so the last two, we're just doing 2 operations on these numbers. So the first operation is your root. So you're taking the cube root of 8, and then you're squaring that number. And then you're going to take the 4th root of 16 and square that number. 4th root, not square root. The denominator is the root. Okay, so the cube root of 8 is what? The cube root of 8 is 2. So this number is a 2. So what I really have is 2 to the power of 2. So my final answer would be 4 for question number 6. So you would actually have to show the steps. Now the 4th root of 16, not the square root of 16. What number to the power of 4 is 16? 2. The 4th root of 16 is 2. So again, oh, that's supposed to be a 3 on the outside. I did not mean to put a 2. Let me fix that, sorry. Okay. Because my index is 4 and the power is 3. So that should be a 3 on the outside. So the 4th root of 16 is 2. And then we're taking 2 to the power of 3. 2 times 2 times 2, and that would be 8. And that's your final answer. We'll pick up at this number 8 tomorrow. That's actually it for today. So use this time. If you have questions over homework 2, homework 2 was due yesterday. You can turn it in yesterday or today for full credit. Homework 3, though, is due today. So there's a lot of homework. Make sure you are checking Canvas. When I put that up yesterday on the first day of school, and I think I showed you all again, go to Canvas, check the due dates. Don't let it all pile up on you. Homework 3 is over interval notation. That's due today. You can also turn that in tomorrow for full credit.